Today's lecture is over 2.6 transformations of graphs. So how do we use common graphs that we know to create new graphs? What we're going to do is take a graph and shift it up and down, left and right. We're going to stretch it, make it taller, make it wider, or compress it, make it thinner, and reflect it over an axis. So first thing, we need to be familiar with the most common graphs. After last night's homework, you all know about y equals mx plus b, right? What's that graph look like? Straight lines. Very good. So straight lines with various slopes. What about y equals 3? Horizontal straight line. Very good. Identity function is y is equal to x. I accidentally covered it. Are we familiar with parabolas? Y is equal to x squared. Okay, so I want you to very easily plot 5 points of a parabola. And those 5 points are 0, 0. 1 squared is 1. 2 squared is 4. And I want you to graph on the other side very quickly. -1 squared is 1. -2 squared is 4. So you can do this ratio of right 1 up 1, right 2 up 4, and write the u through it. Any questions about parabolas? This is just the basic parabola, x squared. Are we familiar with the basic cubic? Y equals x cubed. So notice how the right side looks very similar. What's 0 cubed? 0. 1 cubed. 1 times 1 times 1 is 1. And 2 times 2 is what? 8. I should probably draw that point up there. So the right side looks like maybe a more steep parabola. But why is the left side different from my parabola? Yeah, inflection point. But when we plug in a negative number, what's -1 cubed? Now it's negative, whereas -1 squared was positive. So that's the main difference. If you have an odd exponent, negative numbers will be negative. So -2 cubed should be -8. All right, the other one we should be very familiar with is x squared. What's the domain? Sorry, square root of x. What's the domain of square root of x? Yes, you cannot take the square root of negative. X must be greater than or equal to 0. So if we plug in x is 0, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. It's half a sideways problem. We're missing the other half because the domain is only positives. All right, extra credit. Who knows the equation for this graph of the green line? Not really extra credit, but I'll give you a thumbs up. What's the equation of the green line? Yes, that's right. Y equals negative square root of x. So, where does this come from? It looks like a sideways parabola. Y squared is equal to x. If we square root both sides, you get y is equal to what? Close. Plus or minus square root of x. So this is two separate functions. The top half, y equals positive square root of x. The bottom half, y equals negative square root of x. If we graph just the square root, it's just the top half because it's assumed only the positive square root. Any questions about this? Okay, cube root looks very similar to cubic, but it's reflected across this line, y equals x. And if you flip it around that line, you get that sideways s. So anyway, you can plug in values. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. And the cube root of -1 is -1. Cube root of -8 is -2. Are we all familiar with the absolute value? What's the absolute value of 0? 0. Absolute value of 1 is 1. Absolute value of 2 is 2. And so it looks a lot like the line y is equal to x on the right-hand side. But on the other side, absolute value -1 is +1. Opposite value of -2 is +2, and so on. So it looks a lot like y equals -x on the left-hand side. So we'll want to memorize absolute value x. What does that graph look like? And finally, y equals 1/x. And we'll talk more in depth about this one. Actually, for the homework, you should reference this, but I'm not going to ask this one on the first test. I'm going to leave this for the second test, rational functions. I don't want to talk about it until we can talk about it in depth. Okay, so first thing, translations of graphs. How can we shift up and down? F of x can be considered a y value. And if you add something to the y value, it's going to change the height. So it's a vertical translation. If you subtract something from the y value, it's going to make the height smaller. So it's going to be a translation downward. So with that in mind, let's do part A. Can anyone tell me what this graph is? Oh, actually, it says it. Never mind. Yeah. F of x is equal to x cubed. But you can recognize that based on that somewhat S shape, right? We want to translate it in what direction for part A? Yes, that's right. Up 3. What I want you to do is to look at every point, for instance, this origin. And I would like you to shift it up 3. 1, 2, 3, because of the +3. Shift up 3. And that's our new point, center of the graph. Then I find another point on my graph and I shift up 1, 2, 3. And I want to connect those 2 points in a similar manner. So just how I have this curve going up, I want this curve to go up through these 2 points. I have another point down here and I shift it up 1, 2, 3. And I want to connect the dots in the same manner. And that's going to be enough for us. But if you want to be more precise, you can pick another intermediate point and shift it up 1, 2, 3 to get another point that your graph passes through. I'm going to recommend that you practice graphing some of these on paper, not just dragging it on Alex. You can click on the graph and just drag it. Maybe practice doing what I'm doing here on a piece of paper so that you're prepared for the test. All right, any questions about this? So how would it change if this was a -3 instead of a +3? I would shift down. Very good. Now we'll talk about horizontal translations. What if I add a number inside the parentheses? So inside the function, if I add a number, it does the opposite of what you might think. Because the x has a value added to it, we're going to shift left instead of right. Does that bother anyone? No? We're okay just memorizing that? So if I add 2 in here, what direction does my graph shift? Left 3? You're okay with that? Why doesn't it go right when these are positive values? The +3 shifts up where it's positive. Yeah, why is it opposite? It's on the inside. So I'm just going to show you x cubed, and then x plus 2 in parentheses cubed, and talk about why we shift left as opposed to. That way, at least it's intuitive. At one point, you went through it. So what's the most important point to plug in usually? Usually 0. 0 cubed is 0. Then we plug in 1 and 2, -1, -2. -1 cubed is -1, -2 cubed is -8. 1 cubed is 8, 2 cubed, no, it's a lie. What's 1 cubed? 1, and 2 cubed? 8, thank you. So in one case, I'm cubing 0, right? But if I have x plus 2, I'd be cubing 2. So it would be looking a lot more like this. So the way I think about this is, what would I have to plug in to get the same y value of 0? to make this 0, what would I have to plug in for x? I would have to plug in -2 to get a 0 cubed. So I have to go backwards and undo the +2 with a -2. And that's why we're shifting to the left. So in a similar manner, if I'm looking here and I say, I would really like to get -1 cubed, x plus 2 cubed, I'd really like to get an answer -1. So in order to do that, I would have to plug in -3. -3 plus 2 would give me a -1 cubed. So just remember, if it's inside the parentheses, in order to undo that +2, I have to shift left. -2. So if we do that shift for h of x, I take this point in the middle, shift left 2 to make this point. I can take this point here and shift left 2. But it's really every point on the graph that we're shifting left to. And we connect the dots in a very similar manner. Why are my points disappearing? I don't know how to do this. Okay, on the other side, if we shift this point to left 2, we then get the rest of our graph. Okay, so in red, this is function h of x. Any questions about this? Okay, for part C, what do I need to do? I have two things going on. I have something on the inside and I have something on the outside. On the inside, what am I doing? Which direction? Shift right. On the outside, I'm doing what? Shift down 4 because of this -4. Which one should I do first, or does it matter? So in this case, it won't matter, but you want to do inside parentheses first, generally. So I want to shift right 1 first, and then shift down 4. In this case, it won't matter, but when I have stretches and shrinks, it will matter. I'm first going to shift right 1 here, and then down 1, 2, 3, 4. We can shift this right 1, down 1, 2, 3, 4. And we connect the dots in a similar manner. We shift right 1, down 1, 2, 3, 4. And this is the graph of k of x. What's that? The last dot, I shifted 1 and down 4. Right 1 and down 4. We do this for every point on the graph. I just picked the nice points, but you could pick an arbitrary point and go right 1 and down 1, 2, 3, 4, and get another point on the graph. It's really every point. There's infinitely many points that we're shifting right 1, down 4. Okay, any questions about this? We next talk about reflections. So what if we multiply by -1? If you think about this as the y value, if a positive y value becomes a negative y value, it's a reflection across the x-axis. So for instance, if this is a point 1, 4, if the y value becomes negative, it would become 1, -4. So whatever that distance is away from the x-axis, you have a point equidistant on the other side. So we identify this as the graph of the absolute value. Maybe just to rehash, do you guys recall that the absolute value of x graph looks like this in red? This is the absolute value graph. And the graph of f would be shifted what direction? Left 2 and up 1. Does that match? 1, 2, up 1. And every point matches, right? I take this point, left 2 and up 1. Okay. Now, this graph that we have in blue, if I write this function and I multiply by -1, I would get the negative absolute value, x plus 2 minus 1. Okay, but to deal with this negative in front, we reflect across which axis? The x-axis. I take a point, this corner is the most important point. I say the distance away is 1 from the x-axis, so I go 1 away on the other side, and I graph that point. I take another point here, for instance, and I say the distance away from the x-axis is 2. So I go 2 down away and get this point. And the line going through those 2 points creates this line. On the other side, I have a point here that is 3 away from the x-axis. So I go 3 away on the other side. I get this point, and I do a line passing through those points. This is the graph of g of x, or negative f of x. Any questions about that? I found a point on the graph, and I count how far is it from the x-axis. You could. So what you could do is say this point here is -3, 2, and I make the y value negative and the x value the same. -3, -2. If you'd like to do that. There's more than one way to do it, but the x value is the same. Okay, part B. What if the negative's on the inside? F of negative x. Now the x value has opposite sign, not the y value, which means you reflect across the y-axis. For this portion, I take my point and I say, how far is it from the y-axis? And I count opposite. That's my new corner. Okay, so where does this point go? -3, 2 becomes what? Very good. The x value is opposite. 3, 2. So the y value stays the same. And the x value is opposite. And that line through it becomes this line. It's been reflected on the other side. Here's a tricky one. What about this point 0, 3? Yeah, -0, 3 is the same point, right? So this is my other line. And this function is h of x. All right, any questions about this? Next, we get to compressing or stretching of graphs by a constant. So I really want you guys to think of f of x as the y value. So if I multiply the y value by 3, the y value is 3 times as large. Y value is my height. If my height is 3 times larger, it's a vertical stretch. How do I make something smaller? What would I have to multiply by? A fraction, below 1. So this is saying for values larger than 1, like 3, it's a vertical stretch. If I multiply on the outside. But if I multiply by a number between 0 and 1, so something like 1/2 or 0.98, because it's less than 1, it's going to compress my graph vertically. All right, any questions about that? So let's try part A. I have a function, and I'm multiplying by 2 on the outside. So that means, is it a vertical stretch or compression? Vertical stretch. And why? Yeah, because 2 is larger than 1. Uh-oh. My pen stopped working. Oh, yes. Check my audio. Checking. 1, 2. Does that mean it's working? Can you guys on Zoom hear me? Continue recording. Hello, can those of you on Zoom hear me? Noah, Samuel?
Yeah, I can hear you.
Oh, thank you. Okay, what are we doing? Stretching. Vertical stretch. 2 is greater than 1, so we stretch. But vertically. So I take a point and I make it, that distance from the y-axis is 1. I make it twice as big. 2. I take another point and I say, what's this distance? 1, 2, 3, 4. Let's make it twice as big. 5, 6, 7, 8. So now, what about this point? Its distance from the x-axis is 0. We make it twice as big, still 0. So my point stays. So my graph looks like this. Are there any questions about that? Can we do it on the same side? Or sorry, on the other side? This distance from the x-axis is 1. If you make it twice as big, it becomes 2. So this point, -1, 1 becomes -1, 2. The y value is twice as big. This value here is -2, 4, but we make it the y value twice as big, -2, 8. Any questions about that? And so this is the graph of g of x. Horizontal stretch or compression. What if I multiply by a constant that's larger than 1 inside? So f of 3x, let's say. 3x. It's a horizontal compression. So why is it opposite? If it's on the inside, I'd have to plug in something that's 1/3 as big to get the same result for x. So it's a compression toward the y-axis by a factor of 1/c, or in this case, 1/3. And how would I make sure that I do a horizontal stretch? Oh, typo. Please fix these notes. What should this be? F of c times x again. Okay, so for instance, f of 1/2 x would be a horizontal stretch, because to get the same result, I have to plug in something for x that's twice as big. So it's a horizontal stretch by a factor of 1/c. 1/1/2 is just 2. It's just the reciprocal. Let's try to apply this to the next problem. To graph h of x, the 1/4 is being multiplied inside the parentheses. So that tells me, is it horizontal or vertical? Horizontal. Is it horizontal stretch or compression? So inside the parentheses, if you do it to x, it's the opposite. It's going to be a stretch. Okay, why is it a stretch? So I want to talk about this point here. Let's talk about this point. I'll make this in red. This ordered pair is 2, 4. You agree? Okay, so normally this is a graph of f of x is equal to x squared. So I'm doing 2 squared is equal to 4, right? But if I want to get the same height for my other function, the same height for my other function, I would say 1/4 times what squared would give me 4. And I want to square 2. I would really like to square 2. And to get 2, I'd have to do something 4 times as big as 2. I have to plug in 8. So now if I plug in 8, I would get 2 squared is 4. So it's doing a horizontal stretch. It's stretching this line out this direction. You can just memorize that if inside the parentheses you're multiplying x by something, if it's between 0 and 1, if it's smaller than 1, like 1/4, it's going to stretch it by the reciprocal. What's the reciprocal of 1/4? 4/1. The other way to think of it is this distance is 2 from the y-axis. Let's make something 4 times as big. 1, 2, 3, 4 times as big. The next one, the next point here, this point is how far away from the y-axis? 1. So if we make it a horizontal stretch by 4, let me write this out. This is a horizontal stretch by, you flip the fraction. 1/4 becomes 4/1. So that distance of 1 becomes 1, 2, 3, 4. So I now have 2 points. Now the origin, 0, 0, is how far away from the y-axis? 0, right? If we stretch it by 4, what's 0 times 4? 0. So it stays where it is. And now I can draw my line through these points. And on the other side, it will look the same. So this distance is 1 becomes 4. This point goes out here. This distance of 2 becomes 4. This point comes out here, and we draw the other half of the parabola. That is one wide parabola, h of x. Any questions about this? So if you do the operation x, it's counterintuitive. It's the opposite. All right, any questions about this? Okay, part C, we're going to combine multiple things at once. I really want to draw this somewhere else. How can I do that? I'm just going to redraw this over here, off to the side. I think it'll be too cluttered if I do this on the same graph. Okay, so I have my normal parabola, y is equal to x squared. And it looks like this. Now, I really need to follow these guidelines or your graph will be incorrect. First, you must do horizontal shifting. Second, you can do vertical stretch, horizontal and vertical stretch and shrink. And third, you can do reflection across the axes. And finally, you do the vertical shifting last. So I want you to think about this as working inside out, but make sure you always do the horizontal shifting first. So if I look at this graph, I'm going to rewrite this. K of x is equal to 1/2 times x minus 5 squared plus 2. What do I need to do first? Shift which direction? Shift right by 5. That's the first step. So if you shift up 2 first, you'll get the wrong answer. Okay, what should I do next? On the outside of the square, I'm multiplying by 1/2. So if on the outside of the function you multiply by 1/2, is that vertical or horizontal? It's vertical. On the inside, if you do it to the x, it's horizontal. Right? I subtracted 5 from the x, so that's why it was horizontal shift. Okay, vertical. Is it a compression or a stretch vertically? 1/2 is less than 1, so it's a compression. Vertical compression by 1/2. And what's the last thing we do? Add the 2. So that would be a vertical, because on the outside of parentheses, everything on the outside is vertical. Vertical shift, what direction? Up by 2. Okay, so I'm going to shift right 5. So this point here goes 1, 2, 3, 4, 5. And then I draw all the points around it. Step 1, I shifted right 5. What's step 2? Vertical compression. So I say, what's this distance from the x-axis? 1, I want to make it half as big. I say, what's this distance from the x-axis? 4, I make it half as big. And anything on the x-axis, its distance away is 0. So my graph looks like this. On the other side, you do the same thing. Distance away, 1/2. Distance away, 1/2. So this is step 2. is a vertical compression. And the last step is a vertical shift upward by 2. So the red graph, I just move it up 1, 2. And every point I move up 2. Okay, and so the purple line is my graph. I'll label this K of X. All right, any questions about this? All right, next part D. I have V is equal to negative 2x squared minus 20x minus 50. I'm going to complete the square on this. Let me zoom in. Negative 2x squared minus 20x minus 51. If I want to complete the square, I really want to factor negative 2 out from the first 2 terms. X squared plus 10x minus 51. What's that magic number I want to add to the inside to make it a perfect square? Yeah, you said 10 times 1/2 and square it. So that would be 25. I'd really like to add 25 here, but that will change my function. I can't just add 25. I have to add 0 to make sure it's unchanged. And the manner in which I add 0 will be plus 25 minus 25. Are there any questions about this? Do you agree that 25 minus 25 is 0? Okay, so I just add 0. I didn't change my function at all. This portion is a perfect square. What does it factor into? X plus 5. Very good. Plus 5 squared. But that's only the plus 25. I still have the minus 25 in here. And I still have the parentheses and the negative 2. So then I distribute the negative 2 to both terms. And I get negative 2 times x plus 5 squared. And I get negative 2 times negative 25 is plus 50 minus 51. So my final answer is negative 2 times x plus 5 squared minus 1. Okay, so in order of operation, I should do what first? Inside, so that would be first what is that? X plus 5 means shift, stretch. This is, when I do it to X, it's horizontal. Shift, because I'm adding 5, I shift which direction? Left 5. Okay, so I take this graph, this blue graph, and I shift it left 5 to get this graph here. Okay, so this is step 1. I shifted left 5. Then I do what next? Just the positive 2 would be a vertical, because it's on the outside of the parentheses, vertical stretch by a factor of 2. So now everything is twice as high. This distance becomes this distance. And same thing on the other side. This distance becomes this distance. That's my second step. What's my third step? Then I do the reflecting. So the third step, I reflect over which axis? So the y values become negative. Is the reflection over the x-axis. So this purple graph goes upside down. Whoops. So if I make this purple graph upside down, then I have this graph is my third step. And finally, I shift what direction? So the fourth step, shift down by 1. And I get my final graph here. And this is the graph of, we call it V of X. You do not have to do all those in-between steps, but you do need to do the horizontal shifting first. and the stretching and compressing before you do the reflection. And vertical shifting has to be last. Okay, use transformations of graphs to do this function. So you could always plug in points just to double check. You could plug in x equals 2 and x equals -1 and so on. But I want to use translations of graphs. So what's the base function here? The original function will say f of x looks like square root of x. Okay, so square root of x goes through 0, 0, 1, 1, and 4, 2. This is f of x. So I should do what first? Horizontal shifting. Should I shift what direction? Left by 2. Okay, so I take every point and I go left 2. Every point goes left 2. And this is my new graph, left 2. That was my first step. I'll label that 1. What's my next step? I need to take care of this negative. That negative on the inside does what? Reflect. And the x value is the opposite sign. So I reflect over the y-axis. Okay, so I take a point. This point is 2 away. So I go 2 away on the other side of the y-axis. This point is 1 away. So I go 1 away on the y-axis. And I connect them in a mirror image. It has to go through the y-axis at the same point. And this point is 2 away. So I want something 2 away on the other side to finish my graph. Okay, so this is step 2, a reflection over the y-axis. And what's my last step? A reflection, or reflect over. If the negative is on the outside, you reflect over the x-axis. So now this point's 1 away, comes 1 away on the other side. This point 0 away. This point is 2 away. So we do 2 away on the other side. And we connect those 3 dots. So the red line is my final graph of v of x. Any questions about this? Okay, we have half a minute left. Which one? Let's do this one. Yeah. So the inside says do what? Horizontal stretch by what factor? By what's the reciprocal of 1/2? By 2. So I take this point here and I say this point is 1 away from the y-axis. I want it 2 away. So this is my new graph. This point is 2 away. I'd like it to be 4 away. So this is the rest of my graph. So this point here is 1 away. Let's make it 2 away. And I connect the dots here. And this point is 2 away. Let's make it 4 away. So I connect that. Okay. This 1/2, we do what? Vertical compression by what factor? By 1/2. So all these peaks are going to be now half the size. Everything that's at 0 stays at 0. So the peaks are half the size. And finally, if we take care of that negative sign, what does that do? It flips it across the x-axis. So this reflects over the x-axis. So this 2 away becomes 2 away on the other side. And this red graph is the graph of y. Or I don't know what we're calling it. This is our new y. We'll call it y2. Yeah, looks like negative sign. Okay. Any questions, bring them tomorrow. I'll happily go over them.